Thank you. So in this talk, I'm going to try a new thing. I'll brand it statement-driven talk. You can use it. Just don't forget to mention my name. Slides will be statements, and I'll do the explanations then. All right, me. I'm a nice guy. Seriously, I am. But I will sue you if you violate my trademark. I like hanging out with my friends, and I am passionate about. I'm dedicated to my passions, and Hasql turns out to be both my friend and my passion. You might know me as, oh, this is screwed up a little bit larger. Can everyone see? Okay. So yeah, you might know me by this project. You might have heard about it or read about it on Reddit. That other project, Storm Framework for Scala, is an interesting fact. I no longer actively develop this library, but I am its author. So I have created an ORM library in my life. I'm one of those guys. Please keep that in mind whenever I start bashing on ORMs. Also, I have worked with Scala, so be cautious. Just a second. And yeah, of course, I'm the author of HaskellX. It is a problem to name this library, so I just call it HaskellX, because everyone gets confused otherwise. Our common problem is that we need to attract more people into Haskell. For it to become successful, we need both more employers and people looking for jobs. This means that we need to learn to approach both of those audiences. We know this. We know this by heart, that it doesn't matter what runtime you're in. It doesn't matter as much as the quality of your algorithms. But we never tend to take this seriously because rarely do we see any practical examples of it. And we know that C is faster than Haskell. Nobody would argue. But that doesn't necessarily mean that all programs, all applications written in C are faster than those written in Haskell. And we do have some examples. We have some projects that have beaten their analogs in C or other low-level languages. But to do better, we need to have more of those projects. We know that. We have lots of polished, by centuries, abstractions which were developed by the smartest people on this planet, by mathematicians, and they've been developing this for centuries, not decades, as it applies usually for other languages. And we use those abstractions. But whenever someone starts talking about them, the audience seems to be, to become that. They start washing off whatever you'll be saying next as highly academical and unpractical jibber-jabber. But think about this. Centuries of research by the smartest people of this planet. And people just ignore it. This is just beyond there is no reasonable explanation to this. But we still need to get through it. I believe that for that, we need some more success stories. They tend to say that Haskellists live in a mythical world. And we don't do real applications. We don't deal with real problems. And that is why we need projects which deal with real problems. We need what is more practical than a database integration problem? Because I can't imagine any real-world application doing without a persistence layer. Most of them do. And Postgres lately has become the de facto standard of SQL databases. So it's a nice choice to, start improving ourselves in the area of. The ultimate goal of this library is to beat libpq. libpq is a low-level C library which comes packed with Postgres distributions. So it is the default library used by every language there is to communicate with the database. There are some projects which deal with the binary protocol which drives this library under the hood, but there's really few of them. And HaskellX now tries to become one of those. And this is why I've set the goal to beat C, this C project, to make another success story for us, because it's easier to brand. You have a C library, and then you have this mythical Haskell for some reason outperforming it. This is something we need, and we already have certain success in this area. We have a project named Postgres, which is a RESTful web server which abstracts over the Postgres database. Inside of it, it is implemented based on HaskellX. And this project is really popular. I mean, it has something like 9,000 stars on GitHub. So we have some success there. And making HaskellX better will make that project even better than it is right now. And those guys are actually actively pushing me to implement new stuff. And they were the reason that I started working on implementing the low-level binary communication without libpq. My plan for this talk was to show you lots of slides with benchmarks where I beat this library. But unfortunately, it is a really hard task to optimize it, because I'm dealing with very low-level stuff like sockets, doing it directly. And I have some success, some degree, I would say, of success. I've managed to get on par on the performance level with libpq, with the library which is completely implemented in Haskell. Yeah. Yet, my plan was to beat it. First of all, and I've noticed lots of issues with performance, like, for instance, I have this library doing garbage collection 50% of the time. This is bad. This is something that I'm working on, that I'm trying to optimize. And once I do this, we could expect even a 50% decrease. At least, I hope. And having that fact, I still needed to release a sort of an MVP for this project. And I've arrived at a solution which lets me both have the stable version, which is battle tested, which is behind such projects as Postgres, still have it be the primary release, and in the meantime, to be able to release those experimental versions which I'm currently working on. And I think this program generally apply to other projects in the Haskell world. Can you see a pattern here? All of those libraries, for some reason, they live in this zero world, I would say. For some reason, we have associated one of those most important all of those most important libraries with some kind of experimental state in their versions. And what is the point in having this 0? There is no explanation in PvP, and if somebody doesn't know, PvP is our versioning policy. Officially, they say that it's just another major version, so we just have 2. Why and what for? Some people say that we can use it for marketing. All right. Maybe. But the fact is the fact. They live in some kind of experimental version space so far. And it's been for years. I'm sorry? So a solution that I've reached is as simple as those 2 statements. If you look at it, it might seem like, yeah, what's the problem? We do it this way already. But we've never considered using the 0 space after releasing something in the after version 1 point or 2 point to still keep releasing products in the 0 space. And that's what I'm targeting at. The development branch of my project will live in the 0 space, and all the stable releases, which are battle tested, will have their major versions start with something larger than 0. And thus I will get the benefits of both worlds. I will have rapid development. People can already use this raw library that I'm working on, the state of it as it is now. You can already depend on this experimental, state of my project. It now lives in the version 0.20, and the battle older version 0.19 has now become number 1. So what's wrong with this C library that I'm trying to compete with? There is 2 major problems. But on the large overview, it is a really primitive library. It is filled with, very simple, simplistic approach to problems. And in the end, it arrives with some major, in the end, we get some major issues like the whole response for any query that you get gets cached completely, gets allocated. You get the memory, the whole response allocated before you can processing it. So for instance, if you have a query with thousands of rows returned, you will have to first load all of those rows, and only after that can you start folding through them or do whatever you want, turn them into lists or vectors. And this library doesn't do pipelining. If you don't know what pipelining is, it is that. Just a second, I'll make it, no, not smaller. On the left side, you can see that's the client. For instance, that is LibPQ or our application using LibPQ, and that is the server being the database. To perform some selects or some standard operation, the client sends a query to the server. Then it waits for the server to process this query and receive a result. Only after that can it start sending another query. It needs to get a result of the preceding query always, just to be able to execute the next one. But you might not need that. You might want to have 2 queries which have no relation in between. And you would rather execute them in parallel like this. You can send all of those queries that you want to execute in parallel. And you, while still sending those queries, you can already start receiving the results. And it gets even worse under the hood. When you start some query, like select, the application actually sends multiple requests. It's not just one request. It's like parse query, bind, and only then execute. Several requests to the server are made. And that is forced upon you by this library. You cannot do that with libpq, never. This was one of the most important reasons why I started rewriting Hasql, because before that, it was based on libpq and that model. Oops, sorry. That looks terrible. So here's the first intro of how you can do queries with that library. It provides layers of abstractions. One abstraction gets executed by the other. It always feels like putting Lego pieces together. And if you try to bind two pieces which are, you can't bind something that doesn't make sense. You cannot compose such code. And this is all enforced using types and abstractions on you. All those abstractions are mathematically correct. All of them are either conservariant functors, applicative functors, monads. It depends upon which abstraction you're dealing with, but they all are. So the first abstraction that we see here is statement, which is a pro-functor. So it has an input and it has an output. The input is, in this case, some value which is day. Thus, we map to date values, timestamp values on the database side. And as a result, we get a vector of rows, which are represented by text and date. To create this statement, we use this function, and we say that it's going to be prepared, which means that it's going to be sent to the server once. The server will parse it and optimize it, and after that, we will use some name to call it again. And so the server won't need to reparse it all the time, every time that we use this statement. But I gotta say that actually Postgres does parse very fast. So this doesn't make the difference between unprepared and prepared statements is actually negligible in Postgres. Then we define this actual statement as a template according to the Postgres standard, which has those dollar prefixed placeholders. Then we specify how we encode the parameters to this query. So the parameters being every value that should be placed instead of the placeholder. And in this case, we only have one placeholder. So we specify it as a parameter. You can see another abstraction here, encode params. Then that abstraction executes encode param, another abstraction, which specifies that this particular data type will be a primitive value, because we can also have arrays or composite types. Those are separate encoders. They are more complicated, but the logic is always the same. You get one piece executed by the other, and it's like putting pieces together in Lego. It always feels like this. In the end, we specify that the actual data type will be dates on the database side. And we specify how we want the results decoded. So here is the important difference. We specify that we're going to fold through those rows. And we use the foldle library by Gabriel Gonzalez, which you've seen today, the perfect library to get composable folds to specify how you want a large data set processed instead of manipulating vectors or lists directly. You have a holy. I'm sorry. It lost the signal. Sorry? How can I wake it up? The computer is. All right. Okay. So here we say that we're going to fold all over those rows using this fold specification, which is provided by the foldable library. In this case, we are just going to fold them into a vector. But you could just as well do some processing on this data. You can count rows, or you can get some analytics from there, statistics, some complex computations. Then we specify the decoder for each row that we receive, which is, in this case, since it's name and birthday, something wrong with day, I don't know what it is. But OK, so name obviously is a text, and birthday is a day value. So we need to specify how to decode such a row, a single row. And we specify it here, which is using the applicative functor. Using the decode row abstraction, which says that we're using a primitive value for the first field, which is text, and for the second, it'll be dates. So you are already introduced to layers of abstractions here. And yeah, it's a statement again. So I didn't violate my promise. Every slide is a statement, so far at least. Just a second, sorry. To actually execute this statement, you would have to go through two other layers of abstractions. The first one, well, connection, you get what connection is. It's actually the resource that, and everything related to that communication with the database. Sockets, all the internal caches, all those things are inside this object, but you don't have to deal with that. All you need to deal with actually is just the session abstraction and the batch abstraction. The session abstraction is something you can consider it as a reader T over connection, which also handles exceptions. So reader T over accept T, something like that. It is actually a free monad under the hood, but either way. So it is a monad. It is sequential. It lets you execute one query after the other and use the results of the first query to provide or specify what to do with the next one. And all it can do, it can execute batches. And every batch, a batch abstraction is applicative functor, because applicative functor is what lets you do parallel things. So this is what specifies how you can do the pipelining that I've described before. When you compose multiple statements here, you get them executed. All the requests that are associated with those statements, they get sent as a single TCP request to the server. So we really optimize the network latency. Hold. Excuse me for this. Such a sleepy computer. So here's an example of what we can do. Notice the difference. We have many days now. We can easily just use traverse in the batch monad, not monad, sorry, in the batch applicative functor to execute lots of, well, as many as we have days, that many times we will execute our previously specified statement. And we will, that particular example actually outperforms, on the tests that I've done, outperforms libpq by a factor of at least 6. 6 times faster than libpq. But I'm pretty sure it largely depends on the amount of queries that you're going to execute. So the more queries you execute, the better it performs compared to libpq. So there is an achievement already. But since in other situations I would expect it to perform better, I don't claim victory yet. I often get asked by people, why don't I use abstractions like from row, to row in such libraries as PostgreSQL Simple? And why do I use those contravariant functors and things like that instead? Well, look at this example. Just a second, let me make it larger. So let's suppose we have some function which somehow executes this query, and we have an instance of from row for this data type defined somewhere. Look at this query, and look at that one. Look again. Notice the difference? The difference is that the only thing that's changing, for some reason, it slides over. I don't know why, but keeps sliding. Oh, OK. All that's changed is that we've changed from the date field to ID, and the program will still compile. You will see you will look at this and see, yeah, all right, it works. I'm receiving person because person is usually defined in some other module, which is something like model, and you don't look at it, and you expect this query to perform as it did, but naturally you've just introduced a bug. And you can't spot it. It's really hard to spot. So basically, this is a leaky abstraction. This is just a proof of that. And another reason for it to be leaky is that we actually, by specifying the instance, we define what the statements are actually doing. So we specify that any statement that returns person should be returning rows of name and date. So we somehow specify the things that are clearly a part of the, have to do with the statement. We're specifying them here and here in 2 places. And usually those places are separate modules. So we have this logic scattered across our project. This is another question that I'm often getting. It can actually, the encoders can actually be monoids, but there are consequences. Look at this example. In the first example is how we can specify an encoder which encodes 2 fields, text and timestamp. And we specify it using a contravariant functor, actually divisible functor, which doesn't have any parameters, as a function which doesn't have any parameters. So the arguments become a part of the specification of the encoder. This is the way it's done in Hasql. But people usually wonder, why couldn't I do it like this? So there would be 2 parameters to a function, and then they will produce some encoding, which can be an encoding of the parameters to the query, which we would pass to some function which will actually execute them. On one hand, yeah, it does seem that this thing is easier to deal with, but there is another hand. Look at this query. So supposedly we are using this encoding method. We have this parameter to that function, which is an integer, and we specify it as if this integer is below some number, we use one encoder, and if it isn't, then we use the other. So we've basically just specified a nonsense encoder. In one case, the application will fail. In the other, it won't, because the database on the other side never changes its types during the query, at least. So this is nonsense. But if it is possible, it shouldn't be wrong, right? We usually expect it. We have learned to expect this in Haskell. This is what types are for, to restrict what we can do. And this clearly violates this scenario. So this is what I'm saying. And I believe that with all my heart. And I must remind that one of the purposes of the Hasql library was to indulge the users to do the right thing, to do the correct thing. There's another problem, is that the Manual API doesn't store any meta information, and by meta information I mean the things that the protocol of communication with the database requires. Things like identifiers of the data types being used for your statements, like those timestamp or integer. We need to somehow tell the database that we are using those types. And we need to count their amount to let the other side, the server, do decoding properly. And those things, if we were using the functions to define the encoding, we would have to compute all those values every time we are passing new parameters. But we don't need that, because we have this information statically. It doesn't change throughout the lifetime of our application. So why does it keep losing this size? So this is an example of a typical encoder again. And we can derive here that there is 2 parameters, and we can derive a vector of identifiers of those parameters just from this query. And this becomes a property of this encode abstraction. It is built once. It is only calculated once. The rest, the actual encoding of the values that you provide, will be done, of course, every time that you provide new values. But we could actually use this API to specify a monoidal API, to provide a monoidal API, using an abstraction like this. So it is a kind of an ad hoc approach which uses the conservation functors which we already have defined, and by specifying the functor that we are using and the input that we are providing to this functor, we can specify that whole information that that's going to be encoded. And this abstraction becomes an instance of monoid. And we could actually use an existing abstraction to do that, to get this monolith instance for free. This abstraction is provided by the construvariant textures library on Hackage. But still, the arguments that I've already provided against the monoidal approach still stand. And here is something that, oh yeah, I forgot to mention. So the purpose of this monoidal approach was to somehow simplify at least the way we need to deal with encoders. And so the final purpose is to make the user's life easier. And instead of taking wrong decisions, which I've explained why with monoidal approaches, I think that it's better to evolve other libraries which would provide high-level abstractions. It could be DSLs which generate queries. HaskellX can easily be used for that. So I mean, popular projects like OpenLI could be re-implemented on top of Haskell, and thus they would become faster, at least to some degree. But another approach that I'm thinking of, I might sometime later release a library which will do something like that, is to generate those statements using a quasi-quoter. And the thing about quasi-quoters is that they are processed during compilation time, which means that we can do lots of checks during the compilation time. First, and the most obvious check is checking the validity of the syntax of this query. So we can get, if we somehow type something not where, but forget about a character or something like that, miss a character, it will get spotted during the compilation time, because we will be parsing and analyzing the abstract syntax tree here. During compilation time, a lot of bugs can be emitted like this. But the question then arises, how do I derive those types? Which encoders and decoders to use here? And the obvious solution for me, this is something projected. This does not exist yet. This is something that I'm considering. The obvious approach would be that we would have some type class which would specify an encoder for the first parameter and for the second parameter, that is for this and for that. And we would have some decoder of the rows that will be produced by this query, this and that. And those identifiers can easily be parsed, and just from the text of this query, we can derive that we have two parameters. We cannot derive their types, but we can derive their quantity. And the same applies to this is not parameters, I mean the results. And the same applies to the parameters. So in the end, this quasi-quoter can produce a function like that. This is the whole signature of this function. But I've already based upon type classes for this task. People can overly use this or use this incorrectly. So I'm kind of inclined not to take this route and take that one instead. This is a valid Postgres SQL syntax. You can actually enforce the data types of all the references that you have there. We can have a data type specified both for the parameters and for the results. So when a quasi-quoter parses this text, it can derive that we have two parameters. The first one will be an 8-byte integer. The other one will be a text, not parameters, results. And we have two parameters, which are text and timestamp. So this is the function that it can produce then. And you can notice that this function will be taking fold as its first parameter to specify how we want those giant amounts of rows processed. And that fold can be folding into a vector or lists or doing analysis, as I've mentioned before. But there is a problem. And sorry for the slides sliding. There is a difference in this slide. It is that we have this text specified with a question mark, and we have a maybe text value here. Why did I do that? The problem with SQL databases is that we cannot expect all the values to be provided. They can provide nulls. This is a mistake, I believe, on the SQL part, but it exists, and we have to deal with that. So if I take this approach, I need to somehow specify in the type that it's going to be either null or the value. So I would have to violate from the actual Postgres syntax a little bit by introducing this question mark. But I still believe that it is worth it. It might be a viable approach. So this is the next project I plan to work on after I finish optimizing all the internals of the actual Haskell library. And this will be, the general approach that I take with Haskell is that the general library doesn't do all this high-level stuff. It merely provides all the tools necessary for you to build up on this. You can make other higher-level libraries on top of Haskell. And there is quite a bunch of other libraries already existing. And those libraries provide abstractions over transactions, cursors, and this will be one of them. Yeah, that's that I mentioned before, and yeah, this is it. Thank you for listening. Any questions? Yeah, please.
Is this on? Just an implementation question. I was just looking at parsing a binary protocol, and I was looking at pipes. What did you use? Because you said you wanted to stream the results.
I cannot use pipes because it introduces a little, but still an overhead. So I'm really using some low-level stuff. The lower level I go, the higher performance I get. And I'm just working on this, squeezing out the performance. So pipes won't do. Yeah. I'm using really low-level stuff. I'm dealing with pointers and that.
Okay, you're a pro.
Are you planning to try to find out more constraints about the table definitions? Because what you presented here is talking about the SQL statement, but there is still much more information in the table definition that you can use to verify whether it's correct.
I see your question. It is actually one of the things that I should have mentioned in the slides, because this question I get really frequently. There actually exists projects which do this kind of analysis on your statements during the compilation time. So you would have some quasi-coder which will crawl out into the database, try to force the database to parse this query and get all the meta information from the database, the running database during your compilation time. This is obviously a higher level approach, and on one hand, it has certain benefits. Of course, yeah, you get your validity of the structure of your query checked. not just syntax. But on the other hand, you're introducing a dependency, a compile time dependency on a running database, on an environment. So the same code base will compile at a certain, within a certain environment and won't in the others. This is really clearly a problem. And this is definitely not something that I would introduce into the core library. If you want to have something like this, you can probably write yourself a library which would wrap Hasql in a way like this. But actually, I must mention that there exists a project like this. It is not based on Hasql, but it does the stuff that I've mentioned. I don't remember the name.
I actually didn't mean getting this information from the database. I meant that when I'm writing the SQL statement, I have some assumptions about how the database, how the table looks like. So I should express my assumptions about the database somewhere and then validate it against these assumptions. And there is a separate problem of validating whether these assumptions are correct in the running database.
All right, I see. This is still a high level approach, but a different one. This is something that DSL kind of libraries do. Is that correct? Did you imply that at least? At least I am implying. You don't need this anywhere. There are DSL libraries like OpenLI. I think I haven't used them much for reasons you might already get. But those libraries do this hardcore analysis of whatever structures you have. And they do this using the structure that they model inside of them, and you address that structure using their DSLs. This is very complicated stuff, obviously, and it is hard to write a good DSL, which will remain stable throughout versions. So it is a different kind of problem altogether, and definitely not something that I want to do.
Okay.
Thank you. Yes, please.
I noticed you have a dependency on PostgreSQL lib PQ in version 0.19, but no, in version 1, but not in 0.20.
Yeah, that's the point. That's something that I've been explaining before. The version 0.20 was only released today. I mean, I've done it today. This is the newest stuff that I was talking about throughout this presentation. But this stuff is an MVP kind of a thing. It is in beta stage, so I don't want to release it as 2.0 or something serious. And I want to claim that it is, production ready. It is not. It is clearly not. It is an experimental thing. So this is why I remain this thing. I keep it in the 0 version space. But the 0.19 version has been battle tested and it's been used in production heavily. I can be sure that it is, I can recommend it. And this is why I have specified a higher version number for it. So that you would get tools like Stack, for instance, automatically choosing the best version, the stable version.
So have you gradually used less and less of the DLL, and this is the last thing now being removed, or is it a major rewrite?
Major rewrite.
Okay.
And actually a second one. The first one performed better than the latest. So I'm pulling my hair out. I see that no more questions. All right, thank you very much.